Hey Youbs, it's Vader here. Alright, this is part 2 of my video of doing a LED color illumination light change. What I'm going to do today is I'm going to show you how it's all together, and show you what I did with making a tool to remove the needles. Okay. Basically, there was a ton of screws back here on this side here. There's a boatload of them, and you take them all out, and all I did was I left a couple in, one so it wouldn't come apart when I'm messing with it. For demonstration purposes, basically, if they're just they're you know, obviously they're a kind of a sheet metal screw, almost not a self tap. They're a flat end, almost a self tap type screw. There's, you know, a bunch of them. There's a boatload of these things. Obviously, you guys seen the bag that I had. So I'm going to throw them in there, and then the other thing that holds this together is these gauges. Now, what I came up with is I had this pry bar. I think I might have got it at Harbor Freight, or I'm not sure where. But anyways, it's a little tiny pry bar, and all I did was took my Dremel and cut this open, this wedge a little bit more. It's a, you know, a nail puller wedge. And I just took the Dremel and ground it out more so it would fit the hollow shaft. And what I found was it fits underneath perfectly, and I'll show you what I mean by that. See, it goes underneath there perfectly, and it rides, and I've got this pressed down in there pretty good where it normally is. And you press it down a little bit. You might have to press down on the display the plastic display portion itself to get it to seat under there, but it fits right underneath there perfectly. And all you do then, you just kind of work it a little bit, maybe even spin it. Let me move my hand here. Maybe even spin it a little bit, okay, to get it up underneath there again, and all of a sudden she'll just pop right off. And this is what it looks like underneath. That's that little shaft I was telling you about that's hollowed right there. Okay, and there's a weight inside there. Again, this one came apart on me a little bit because I was trying to use a flat blade instead of the right tool for the right job thinking. But anyways, that's basically what it is. And there's a hollow point in there. I don't know if you can see that or not. Put a little light on it, maybe that'll help. I don't know if it will or not. Anyways, there's a hollow. It's hollow in there. And then that worked for the same. I'll stick these up here. It also worked for the tachometer one, and it just, you know, pulls it up off that pin, and I'll show you the pin in a second here. Again, this one here, you know, same kind of, it's same scenario. I mean, you know, and if you try to use anything that can only, like a flat blade will hit a small area, the problem you take, the chance you take is busting this. If you break this, this needle's no good to you anymore, because that hollow shaft, you know, it's thin. It's thin, but it's thick. But again, it's vulnerable to snap right in half. You know, you just snap it right off. Now it's stuck on the pin for one, and two, you're out of a needle. Unless you could somehow super glue it and all that stuff, which you probably could, but I don't know. I don't know if I want to take a chance. But anyhow, that's what I ended up using. I've kind of looked around on lots of different things of what I could try. I took a screwdriver, and I thought, okay, if I bend it at an angle, I still need a slot, and on and on and on. But again, this is what I came up with. Just bend it at the right angle, and it gives me, you know, a prying area. And again, if you take it and you spin it, you know, a little bit, you know, you just kind of go around it. Let me go this way. You know, you go around back and forth, and eventually it works it off. So, you know, kind of nothing major tool, that's for damn sure. I could have even used this side if I needed, you know, to get up underneath there a little differently. You know, grind it down to make it thinner if you need to. All kinds of cool stuff possible with that. But anyways, there's a pin right in the center here. I don't know if you can see that or not. Let me try to get a better spot on. I'm sorry. A little better shot on this, guys. There's a pin right in the center of that damn thing. And that's what that pushes down on. There's a little pin on there, a little tiny little pin right there, and that goes to the pot control. And there's a little white, probably a permanent bushing on there, but anyways, that's the stop for the needle. So the needle won't go so far, you know what I'm saying? So they built that. That was nice. They built that in. That was pretty nice of them, mighty nice of them to do that. But anyhow, so anyways, that once those two are off, it's going to allow this to separate, and I'm going to separate it right now and pull this thing apart. And that's basically how it comes apart. Now this is the backing, you know, nothing to her, you know, just the inside, plastic case, you know, nothing major. Let's set this dude aside. And then we have one side of the circuit board. And now these are the meter pots here. Okay, you don't have to fool with them, don't have to do anything with them. Now there is a couple of screws here, and I'll take these out. There's a whole bunch of them actually. Another, you know, part of them screws that were on the back are going here. But there's only a couple screws here. You'll see them when if you ever took yours apart, that actually hold this circuit board to this layer. Okay, and I'm going to pull that apart right now. I just again left a couple screws in it, just so it wouldn't come apart on me. I'm going to put the other one right here, and again for, you know, kind of demonstration purposes. All right, I'm done with that. So now she will come right on off there. Now I've got the this is the display side, the part you look at, separated, okay? And I'm going to show you that in a second here. And in fact, you know what I think I'll do is let's do this. Kind of winging here, guys, so bear with me. But anyways, let me try to make sure. I'm going to aim this down a little bit so we can kind of get right onto her. See that light? Yeah, okay. But anyways, in relationship to this panel, to this circuit board, okay, these are the indicator LEDs. Use this. These are the indicator LEDs right here for your ABS, fuel injection, lights, parking, all that kind of, your parking brakes on. That's what lights them up. All they are is lenses. That's all these are. They're just colored lenses. So I'm not going to change it because they're obviously just clear LEDs. The same with, when I put this back together, these LEDs, okay, and also these LEDs right here light up the temperature, fuel, oil, and all that kind of stuff right here. Okay, and I think in Illinois Trigger calls them pips or something like that. But anyways, the pips on it, knowing where your gas is, each pip was worth a certain amount. You know, you kind of knew, okay, I'm down to 3 pips. I think that's what he's saying. Oh, correct me if I'm wrong there, Illinois Trigger. I appreciate it, Craig. But anyways, this is what lights that up. It's it's almost an LCD display, but it needs an LED to light it. It's not lit by any fluorescent type thing or something. LCD is, you know, liquid crystal, and it has to have some sort of lighting. But anyways, the other thing is, again, relationship to the turn signals are just colored lenses, and they're also controlled by these LEDs. Okay, and then you get to the coup de grace, as they say. The part that I want to deal with. Oh, and by the way, that's right. These are the meter pots, tach and speedometer, and this is what it looks like. That's the pins. If you guys can see this, you know what? Put some light on here. I hope that helps. There's not too much glaring light. But anyways, these are the pins that those the needles go onto. And there's the white little stop. Now, is that removable? No. Okay, good. And then the indicator lights for that metering here are these. And that's kind of the ones I'm interested in. I'm interested in the ones for this and also the ones for the tach, which is these and these. Okay? The turn signal ones I'm not. The fuel and in fact it says stuff on here, I think. Yeah, oil, temperature, and what they got there? But anyways, oil, temperature, and fuel, and what the hell is that? You know, brain fart here. But anyways, doesn't matter. Again, these are the normal displays in regards to ABS. Oh, in fact, this ABS LED is not even in there. So this dashboard could not work on an ABS bike because the LED is not there. So that tells you something. So you got the kind of interesting. They actually there's a legend on the board, which most of the time there is. It says HISS mode. That's really weird. HISS S mode. HISS stands for something, obviously. But anyways, these lights, these LEDs, the ones I'm concerned about are these here. There's 3 of them for the tachometer. Okay, and there's, let's see here, 1, 2, 3, 4, 5. There's 5 LEDs for the speedometer. And if you look at the back, inside here, I don't know if you can see it or not, guys, but inside here is it's just kind of like a membrane that utilizes the light for the reflectivity of the LED. Once it bounces on there, that's what kind of lights it up, helps it glow. There's this layer of membrane, same with this one, that's on there, will actually help light that. Now, come to think of it, well, the LED, yeah, it'd be the oil and temperature and then gas, and that's God, why am in the clock? That's what it was. That's the clock there. And time. Yeah, your time. And your tripometer and stuff like that. It's all there. So that I wouldn't be concerned about. It's just these. And what I'm going to do is I'm going to actually confirm that when I replace these. But these LEDs, let's try to get a little closer here. These LEDs are just standard surface mount SMD, they call them, SMD, surface mount device LEDs. And they're a color. Now I got to figure out on the back here, does it show? No. Alright. Well, if I applied power, anode and cathode, they actually label the cathode as a K. No. What country is that? Okay, well, that's alright. Anode, as we know, in fact, I have an LED little picture here. The anode is the positive side of an LED. Okay, this is just a standard bubble type LED. Okay, those are what everybody kind of recognizes the LEDs as. Christmas lights and all that stuff. But anyways, the cathode is the negative side. So if I took, let's say, 2.2 volts and applied it to the anode side and ground somewhere, okay, which would ground it be like this big part of the surface here, and I would verify which side's ground on this damn thing. See, there's also this little membrane right here. I see this little membrane here. It's a whole bunch of carbon contacts. Oh, that's this here. Oh, you know what, too? That's what it is, too. This thing here, something I just noticed, this is how it reads that information, okay? On this display panel, the back, the inside layer, the outside layer, there's a membrane right here, and this membrane's actually got a piece of carbon in it that causes a contact, and I'll show you in a second here. It's a rail, basically, and this here is fed to this part here, okay, not these two here, these are just LED indicators, but this part here, to give us the reading from each one of these contacts. It's like, you know, your remote controls and all that stuff, same thinking. That's exactly what that is. This just happens to be a bar. In fact, that might even be removable. And it is. It's just a piece of rubber sitting in there with that carbon in it. And, well, it looks like it's maybe removable. But anyways, but that's what that is. I'm not going to remove it. There's no reason to. But anyways, that's how that reads the information that comes from the bike, you know. From its outside sensors, okay, and that's how it's done. There is my biggest concern is, I just want to show you that this chip here, I don't know what the hell that does. Who knows? I mean, some of this electronics. This is a regulator here, and I think actually this here, it's a FET. They even put it down, FET, which is field effect transistor. This FET here is probably the voltage feeding. God, there's variable cap adjusters right here too. There's variable caps right here. They actually adjust, probably for adjustment, voltage adjustment. Try fine tuning this bad monkey. But anyways, these two buttons here, these are the reset and trip odometer reset, time, setting, on and on and on. That's what those two do. These chips, I didn't bother looking at these chips to see what they are. They could be regulators, they could be switches. Don't know. I'm not real sure. But the biggest part is that I really want to dig into was, you know, can I identify from these pins, if I need to attach to these, I could either do it one of two ways. I can solder a wire to this solder pin point and find the hot and the, you know, positive, negative. That actually kind of does the voltage side, and then just that's my tap. I got many ways I can do it. I can put pins on this side and crimp them to a piece of wire coming off of here. I think I'm going to kind of go on this side. The reason being, I can see things happening here. Then, Bandito 2, he's Mike. He's another guy that rides with Craig and I a lot, and he kind of pointed out a couple things with the schematic, the wiring schematic, that you know, they're somewhat labeled. This meter CPU, this meter CPU thing, I think is this rail over here, but I'm not sure yet. I haven't really broke it down enough to determine it. But he did tell me, you know, him and I determined the black-brown wire. Black-brown is used a lot in this wiring train here, and black-brown is positive, is the positive side to this dashboard panel. I made myself some notes here after, you know, when I did some other stuff. The indicator light LEDs, and again, this is what an LED, I gotta get closer to you guys. This is what an LED schematic symbol looks like. See this illuminator? I don't know if you guys can see that or not, but this illumination right here, LED, okay, that's the electronic symbol for it, and that would be one of these bad dudes right here. Okay, so this board is probably, I would say, probably a 2 or 3 layer board at least. That means the internals are being, you know, run through here. So I got to find the common denominator in regards to how to power one of these up, or just hitting cathode anode. And I may just do that. I'm not sure yet. Let me see something here. I needed to. Yeah, I think what I'm going to do next is, not today, but I wanted to kind of break this down and show you guys a little bit, give you the input of what's going on in this dashboard, the actual circuit panel of it and stuff like that. But the the next video is going to be more of the lighting up and stuff. I want to go through a little bit of steps off camera so I don't bore you guys to death of how to light these up. So I want to see what color they are for one. Again, I think what I might do is do anode cathode using this power supply right here. It's a fancy dancy one that I have. This power supply will give me an exactness of voltage and current that I'm going to use to utilize the excuse me, the power application, to apply power to these diodes, LEDs. No, they're diodes, but anyways. So if I determine that I can just hit one here and, you know, just kind of a real small probe, negative, positive, or just find a ground point and then positive and it lights up, that's what I'm going to do. And again, I told you guys I ordered some LEDs. I have some stuff coming. There's an easy way to remove these. One, you can solder tip to the thing and just pop them off. There's another way called Chip Quick, and I'll show you guys how that works. It's really cool. It low temp, so that way you don't damage anything. You don't damage the board, any solder contacts of the board, because that's important. That's what you don't want to go wrong on. So but I've got 3 here, so I'm going to mess with this one since it's the outside one. I'm going to mess with this diode here. It's LED 300, they call that one. 301 and then 308. I'm going to mess with that one first. Number 300, LED 300. In fact, I don't, because this doesn't give you a reference that that's LED 300 on the schematic. It just says LED, an illumination LED. So it's almost irrelevant. But what I'll do is maybe kind of draw it on a schematic, you know, that from you know, LED 300 to, you know, the black brown line, which would be the anode side, to the green, which is ground, to the cathode side. And if I do it that way, that's how you know, I'll do a different drawing obviously, but that's kind of what I'm going to do. This is the different points of it. So that's but anyways, making a note so I don't forget. Anyways, I think that's what I'm going to do. That's how I'm going to do that. So next video, that'll show kind of one of these lighting up, so I can determine the color of it, and maybe even these other ones, see what the hell they look like. They're probably clear, but which they should be, because they already got colored lenses behind them, so like turn signal and crap. So anyways, that's the circuit board, little explanation on it. Really nothing magic here, actually, guys. It's not really that, I don't know why we'd think it's so hard. And you know, there's nothing magic going on here, really. There's not. Now, anybody's would want to go through this stuff, I have no idea. I thought that was a 0 ohm jumper. A 0 ohm jumper is actually a fuse. It looks like a resistor. I thought that's what that was for a second there, but it's not. So anyways, that's where I'm at for now, and we'll get to the science part, the real science part. Actually see chemicals blow up and stuff, portion of science on the next video. So that's it for now, and Vader's out. Hope you enjoyed it. Thank you again for watching. Vader's out.